Hello and welcome back to Algebra, Chapter 5, Section 7. We are talking about systems of linear inequalities. Okay, so in the previous lesson we looked at inequalities. Okay, an inequality, when you graph it, looks like this. That means we've graphed a line, dotted or solid line, and then shaded one of the sides. That side represents all the possible solutions to that inequality. Now we'd want to match these two to each graph. In order to do that, you could either pick a solution and plug it in, see which one it works for, or we can solve this, which I always recommend, solve it for y. So let's move the x to the other side. Remember, it goes across the sign changer, so we have y is less than or equal to negative 2x plus 4. And then this one here, if we move that over there, we have negative y is less than or equal to 2x. Now, negative 2y, that is not in slope-intercept form. So I'm going to have to divide by negative 1. What happens when you divide an inequality by negative 1? That's right, ladies and gentlemen, the sign changes direction, just like so. All right, so here I have an equation with a y-intercept of 4. Check my graphs. This one intersects at 4. So this matches this graph right here. Also, the slope is negative 2. It goes down. This slope is 2x. It goes up 2 over 1. Now, if I have two inequalities, we can consider that a system of inequalities. A system of inequalities and a solution to the system of inequalities is an ordered pair that is true for both of these. So something that's true in this one and in this one. The way that we can check that is we graph both of them on the same graph. So I can overlay this one over here, make these two the same graph, and then I could check where do they overlap. All right, now I can lower the opacity there so you can see this graph. It goes this way, this one goes that way. Okay, where do they overlap? They overlap in this area right here. All of this over there, this is where they overlap. Okay, so any point in that area over there should be part of the solution. So I could pick this point right here, 0, 2, 0, 2, and it should work for both of these. Let's check that. Plug it into the first one. 2 times x is 0, plus 2. Is that less than or equal to 4? Well, 2 times 0 is 0. 2 is less than 4. That is correct. Plug it into the second equation here. And that's the red one. Plug it into 2 times 0 minus 2. Is that less than or equal to 0? Well, that's negative 2 is less than or equal to 0. Negative 2 is less than 0, so that is correct. So that point is indeed a solution for both of these inequalities. And that's how we solve a system of linear inequalities, by graphing. Okay, now we could check if we're given an answer just like I did in the previous example. We take this, plug it in, see does it work for each one. Then it either is or is not a solution. Remember x and y. Highly recommend that you always label your coordinates before you plug them in, so you make sure you get the right one in the right place. Okay, so 5 is going to go first here. 5, is that less than 2 times 3? Well, 2 times 3 is 6, and 5 is less than 6, so that works. Does it work for the second one? 5 is greater than or equal to 3 plus 1. Well, 3 plus 1 is 4, and 5 is indeed greater than 4. So, yes, this is a solution. And this, by the way, is how you show your work. Okay, so don't just write yes or no. Show your work that you have actually plugged it in. Okay, plug in negative 2 for x and 0 for y. 0 is less than 2 times negative 2. Well, 2 times -2 is -4, and 0 is not less than -4. So, no, if it doesn't work for one of them, it is not a solution to the system. Could be a solution to the other one, but it's not a solution to the system of linear inequalities. So, no, it is not. Alright, graph the system of linear inequalities. Okay, I'll always put it in slope-intercept form first. Once it is in slope-intercept form, then graph it. If I don't have an x, that means it's a horizontal line. If I don't have a y, it's a vertical line. So y is less than or equal to 3. Because it's equal, it's going to be a solid line. And 3, 1, 2, 3. This is the y-axis, x-axis. So on 3, we're going to make a solid line. Boom. Next line is y is greater than x plus 2. I'm first going to graph equals. Alright, stop. Let's back up. We forgot to shade. This is an inequality less than this, so we're going to shade all of this down here. Right there. Alright, now we can graph this line. Plus 2, so we go up to 2. X, that's 1x, so the slope is 1. Up 1 over 1, up 1 over 1, and then we can graph that line like so. And now remember, if it's greater than and it's not equal, then that needs to be a dotted line. Okay, so there's my dotted line, and then check which side gets shaded. It says y is greater than, so it's going to be above the line. This gets shaded. Okay. We can always check to see is that correct, the side that I shaded. So I plug in 0, 0. 0, 0 should not be a part of the blue solution. So if I plug in 0 here, that should not be true. 0 is 0 greater than 2? No. False. And it was supposed to come back false. So I shaded it correctly. That means the other side gets shaded. Okay, the solution to this is where these two overlap. So the solution is this line, solid, and this line dotted right here. And then everything in between shaded. So the solution is this right here, where they overlap. And not this, and not this. There we go. My solution. Solution. Graphing a system of linear inequalities with no solution. What does that mean? Well, if I was to graph this on this graph that just magically appeared, then first thing I'm going to do is change this into slope-intercept form. So we do a little bit of moving around. Move this over there. Move this over there. We get y is less than -2x minus 1. And we get y is greater than -2x plus 3. Alright, we'll graph this one. Plus 3 means up 3. And -2x down 2 over 1. Down 2 over 1. Okay, and then dotted line. Dotted line. Dotted line. Dotted line. Okay, and then it's greater, so it's going to be above. So it's all this right here. That's the solution of this one. Blue one is -1. And then the slope is also -2. So down 2 over 1. And also a dotted line. Alright, and the solution is less than, so it's on the bottom of that line. Notice that these overlap nowhere, so there's no value, no ordered pair that I could plug in that fulfills both, that is in both the red and the blue shaded area. So there's no solution to this. Now, if I was to turn this around and said that this was not a less than, but it was a y is greater than negative 2x minus 1. These two, that'd be this line right here, right? Same line, boundary line, but I'd say greater, it would overlap this way. And it would overlap for all of the red area. So the solution to these two would be all the red area. Okie dokes. All right. If we want to write a system, we first write the equations. This one right here, if it's a horizontal line, that's y is equal to, and that's negative 2. And then notice that it's shaded above that line, and it's a solid line, so greater than or equal to negative 2. This line here goes through 0 and up 1 over 1. So that's y is equal to x. However, it's a dotted line, and it's shaded below the line. So, not greater than, but it's shaded below, which means less than. And it's dotted, so no equals there. All right, there we go. Boom. System. Okay, write a system for these. Okay, vertical line, this is x is equal to, and that's 3. And it's shaded to the left, which the left are the values less than. And it's a solid line, so less than or equal. Dotted line right here. This one intersects at negative 1. Okay, always check to see, is your graph going by 2s or 1s? Negative 1, so it's going to be something minus 1. And then the slope is, here's a point, there's a point, up 2 over 3. 2 over 3x minus 1. And then we are shaded above that line, dotted line. So y is greater than this. And these two together make up, these two together make up the system of inequalities. All right, final problem here. You have at most 8 hours to spend at the mall and at the beach. So mall plus beach. At most, keyword here, so you can spend more, which means at most means less than. You could spend 8, less than or equal to 8. All right, m plus b is less than or equal to 8. Next, you want to spend at least 2 hours at the mall. So at least 2 hours at the mall, so m at least, so greater than or equal to 2. And finally, you want to spend more than 4 hours at the beach. So the beach should definitely be greater than 4. All right, write and graph a system. Well, here's my system. We've written it. Check that off. Graph it that represents it. Okay, now, m and b can be confusing because we're used to x and y. So I'm going to change m to x. All right, this is going to be mall. So this is x plus b, and then b is going to be y. So this is y, y. All right, so I will move this over here. Then we have y is less than or equal to negative x plus 8. Y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 right here. And negative x, so down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1. And it's equal to, so that's going to be a solid line. Shabam. There we go. All right. That value down here is 1, 2, 3, 4, 5, 6, 7, 8. 8 hours at the mall or 8 hours at the beach. But we have some requirements here. The mall, which is x, is greater than or equal to 2, so vertical line at 2. Greater than means shade this side. All right, and the beach should be greater than 4. So this is the beach, 1, 2, 3, 4. So horizontal line here. And it should be greater, so dotted line, boom, boom, boom. And that's going to be up here. And there's my solution. Thank you, ladies and gentlemen. See you later.